Hello friends, in this video I will explain you how you can measure the amplitude and the frequency of the signal by using CRO. Okay. For this purpose I am going to use one function generator and one CRO. So first of all, here you can see as it is visible on your screen, this is function generator. Now it is going to be clear. So this is a function generator. On the screen you can see, so this is the function generator which can give the signal up to 1 megahertz. Okay, so these are different knobs for controlling the signal. Okay, for amplitude control, frequency control, symmetric control, DC offset. So these all are different functions. To know more about these different functions, you can watch my other videos of function generator and CRO. Okay, so here I am going to use only how you can measure the amplitude and the frequency of the signal. Okay, so signal here is given from this function generator. Now you can see this is the output of the function generator. So signal comes out, and this is BNC connector. So this is given to the CRO. On the CRO you can see here you have this BNC connector, it other side here it is connected. So CRO, this is the dual channel CRO. So first channel is here and second channel is here. So dual channel means this CRO can take two signals at the same time, and we can analyze according to our need. Okay, and here we have this time per division scale. So these all whatever knobs, whatever things are required for measuring the amplitude and the frequency of the signal, that I will explain here. Okay, so let's start first. So here on the screen, as you can see on the screen, one sinusoidal signal here it is given to this CRO. So if I increase the amplitude, now you can say, okay, now this is sufficient I think. If I zoom in, then you will be able to see in a much better way. Okay, so here it is one knob there is present on the CRO, where double headed, which can be used to move the signal to the left or to the right. Okay, so first of all, now you can see I'm going to measure the frequency. Okay, then after I will explain how we can measure the amplitude. So for measuring the frequency, we take horizontal blocks. Okay, so you can see on the screen of the CRO, the screen is divided into so many different square blocks. Okay, each block it is we can call this as division. Okay, so when we measure the frequency, then we take horizontal divisions or horizontal blocks, and when we measure the amplitude, then we take vertical blocks. Okay, or vertical blocks or vertical divisions. So here for horizontal, so now you can see one complete cycle. So now the signal it starts from here, now complete cycle here it is ending. Okay, so if you are able to see clearly, so it is taking around 2 complete block. Okay, and then after it is a little bit more than 2 blocks. So if you see here, if you again see clearly, if you zoom in again, then you will be able to see that each block divided into so many parts. Okay, so here each block means one division is further divided into 5 subdivisions. Now you can see here on the screen of the CRO that here it is going to be clear that each division, it means each block again further divided into 5 different subdivisions. Okay, so we can say that one division equals 5 subdivisions. Okay, so we will use this concept to find out the frequency. So first of all, this rotate the signal so that we get the complete signal. Okay, now here the signal starts from 0. So it is a little bit fluctuating, but it is approximately, and after that 2 complete block, and after complete 2 block, 1 subdivision it is taking. Okay, so 2 complete block means 2 division and 1 subdivision taking. So I will write down On the copy, how we can find out the frequency. Okay, so two blocks or two divisions. Two division means two blocks. Okay, plus one subdivision, it is one subdivision. Now you can see on the screen that two division means two blocks plus one subdivision. Okay, so now we have to convert the two division and one subdivision into volt. Okay, sorry, not volt, in time, it means in second, because we are calculating the frequency, so we have to convert this into in terms of time. Okay, in terms of second. And when we will convert the signal into amplitude, then we will use that volt. Okay, so for calculating the frequency, now you can see we have to see the time per division scale of the CRO. On the screen of the CRO, it is visible that it is selected to 0.2. Now you can, it is selected to 0.2 millisecond. Now you can see MS written millisecond, 0.2 millisecond per division. Mean time per division means 0.2 millisecond per division. It means one division equals 0.2 millisecond. So one division equals to 0.2 millisecond. Okay, so we can, since two divisions are there, so we can write down 2 multiply 0.2 millisecond. Okay, and then plus now you can see here, then after 2 multiply two divisions, so that's why 2 multiply 0.2 millisecond, then plus one subdivision. Now we have to convert division into, you know what, we have to find out subdivision in terms of division. For that also I will show you how to convert. So 5 subdivision it was. Okay, 5 subdivision equals 1 division. Okay, because each block is divided further into 5 parts. So now you can see on the screen that 5 subdivision equals 1 division. So we can write down 1 subdivision equals 1 by 5 division. Okay, now you can see, so 1 subdivision equals to 1 by 5 division. So we got subdivision in terms of 1 division. So here it is given that 1 subdivision. So 1 subdivision means 1 by 5 division. So I can write down 1 by 5 division. Okay, and here I can write down like this, 1 by 5 division. And now division I can convert in terms of second or millisecond. 2 into, it means I will get here 0.4 millisecond plus 1 by 5 into, I will show you how I am doing. Now you can see here 1 by 5 0.4 I got here, and then after 1 by 5 multiply 1 division. 1 division means 0.2 millisecond, 0.2 millisecond. Okay, and then convert. So here we have 0.4 millisecond plus, here if you divide, so you will get 0.0 and then 4 millisecond. Okay, 0.04 millisecond you will get here. Clear? Now you have to add, so you will get 0.44 millisecond. So that's you got time period. So if you have to convert into frequency, then frequency f is nothing but 1 by t. So 1 by t means this time you can convert into second as 0.44 into 10 to the power minus 3 second. Okay, and then 1 by t meaning 0.44 into 10 to the power minus 3. Here you can write down in terms of hertz. So this is the frequency. Okay, so whatever it was the time period, so I have written here Okay, the time you have to take in second. So that's why I converted millisecond into second. So in this way we can find the frequency. Now next I'm going to explain you how to find out the amplitude. In the same way we have to find out the amplitude of the signal. Okay, so this is the signal. So for finding out the amplitude of the signal, now see what we can do here. For finding out the amplitude, you can see here how many blocks this signal is taking. 1 block, 2 block, 3 block, 4 block. 4 block and 1 subdivision means 4 division and 1 subdivision. Okay, again we will do the same process. So here in this case, what do we have to do? I will show you how you can write. Four division. Okay, hold on. So it is varying. 1, 2, 3. Okay. Now it is approximately. You can see 1, 2. If you so it means 2 complete block this signal is taking, and then after 2 subdivision means 2 divisions and 2 subdivision. So 2 division plus 2 subdivision. Okay, it is varying, but approximately I am taking 2 division and 2 subdivision. Okay, now I am going to convert this. You can see vertical means 1 division, 1 block means 1 division, 2 division means 2 blocks, 2 division, and then after 2 subdivision, 2 division, 2 subdivisions. So now I'm going to show you how you can convert this into. Okay, now 2 division meaning, okay, one more thing, division you have to, if you have to find out what is the value of 1 division, then you have to see this volt per division. For amplitude we see this. So now you can see this is selected to 20 millivolt ray. Okay, so here we can say 1 division, volt per division means 20 millivolt per division. So here I can write down 1 division equals 20 millivolt. Okay, and so that's why means that is clear, means 1 division equals, so 20 whatever it is, so whatever range selected, so that much voltage per division. So 1 division equals 20 millivolt. Now I am going to convert this into different values. Okay, now you can see 1 division equals to 20 volt I got. So 2 division meaning 2 multiply 20 millivolt. So that is completed. So now 2 subdivision. So now I have to find out subdivision in terms of volt. So you know that 1 division equals 5 division. Okay, 5 subdivision. It means 1 subdivision equals 1 by 5 division we can write. Okay, like this. So 1 subdivision we got 1 by 5 division. So now I can put this value here. So I will get 2 into 1 by 5 division here. Okay, because at the place subdivision I can write down 1 by 5 division. I have written that much, and then write down different values. So here you will get 2 into 20 millivolt plus here it is 2 into 1 by 5 into, and division written, so 1 division 20 millivolt, so 20 millivolt you have to write down here, then 5 4 is here, then after here you will get 40 millivolt plus 4 2 is 8 millivolt. Okay, now it is, I think, approximately, now simply add. So if you add, then you will get 48 millivolt. So this is the way you can find. So it means the peak to peak value. Okay, so whatever it is, the 48 whatever it is came, so this is peak to peak value. As you can see on the screen of the CRO, if you see this clearly, so peak to peak means from bottom to top. So peak to peak, whatever it is, what is the values? This is 48 millivolt. Okay, from peak to peak means from bottom to top, it is 48 millivolt. Clear? So in this way we can find out. So now here this is peak to peak. In this way we can find out amplitude and frequency of the signal by using CRO and function generator. Okay, thank you all.